Okay, we've got a couple of things to prove or disprove. So if we're not sure whether we're going to prove or disprove them, it's quite a good idea to actually try out some examples. So the first one, any prime number between 20 and 30. So I have to ignore anything that isn't prime. So can I think of a prime number between 20 and 30? Well, 23 is a prime number. So in scribble space, I'll just have a think about 23. And I think, is it 1 less than a multiple of 3? Well, if I add 1 to that, I get 24. Yes, so that's 1 less than a multiple of 3. Can I think of any other numbers between 29 and 30 that are prime numbers? 25 isn't, 21 isn't, 27 isn't, 29 is. Add 1 to that, it's 30. That's 1 less than a multiple of 3. And those are the only two ones. Oh, so I can use proof by exhaustion. So scribble space, I've done a little bit of work. Now I have to write up a proper proof. Okay, so in a proof by exhaustion written up properly, I've got to consider each possible case, and I've got to talk about that. So I want to say that 23 is 1 less than a multiple of 3, but I need to justify that. So 3 times an integer minus 1, that's enough to show that it's 1 less than a multiple of 3, and I need to do that for the only other example. So 29 is 3 times 10 minus 1, so that's 1 less than a multiple of 3. Okay, but now, for proof by exhaustion, I have to have looked at all the possibilities, so I have to point out that these are the only possible prime numbers between 20 and 30. Okay, so I've tried it out for all the possible values, it's worked for every value, so I can draw the conclusion, but I must state the conclusion, and this conclusion now is valid. I don't actually have to say this, but just for your information, that was a proof by exhaustion because we tried out all the possibilities and every single one worked. Okay, on to part B, and again I'm going to start in scribble space trying out examples. So this is about prime numbers between 30 and 50, so I'm just going to jot down as many as I can think of. So 31 is prime, 33 isn't prime, 35 isn't prime, 37 is prime, 39 is a multiple of 3, not prime. 41 is prime. 43 is prime. 45 isn't prime. 47 is a prime number. 49 is not a prime number. Okay, where do I have to go up to 50? Okay, I've just listed them all. Did I have to list them all? Well, the statement was any prime number between 30 and 50 ends in 1 or 7. Now, actually, before I got to the end of these, okay, I'd got 43. 43 is a prime number. It is between 30 and 50, but it doesn't end in 1 or 7. So as long as I say that, all of that carefully, I've got a counterexample and I've disproved the statement. So what have I got to say to make this a properly worded proof? Well, first of all, I've got to point out that 43 is actually subject to this claim. I have to point out it's a prime between 30 and 50. And I've also got to point out that it doesn't end in 1 or 7. In fact, it ends in 3. Okay, so therefore it's a counterexample. So it's a counterexample to the claim, proving the claim is false, and I've stated my conclusion. So quite a few words there, but that's the level of argument that we need to be giving at A level if we are asked to write a proof. We have to state everything, not just assuming it's so obvious that people will know. So that was the end of that question.